Hello everyone, today we're going to be working on this structure example, and this example is asking us to find the reaction components, to determine member end forces and moments, and to also draw the shear and bending moment diagrams for the beam BC. So looking at our figure that I drew, in this example we have a pin support and a roller support. As you could see, our pin support is right here and our roller support is right here. And some forces that were already given or that are already acting on this frame or on this structure is 10 kips right here, a moment of 50 kip feet, and 5 kips up here in the corner. So as we know, when it comes to pin supports, we know that there's always a y-axis, a y force, and a x force. So there's going to be a vertical and a horizontal force. So we're going to just assume the direction of these forces, and then later on throughout the problem, we're going to see if we assumed correctly or incorrectly. It doesn't really matter, so I'm just going to assume here that the force at the y at this pin support is going to be going upwards, and we're going to call that force AY. From there, we're going to assume our our horizontal force. I'm going to assume that it goes outwards. This is going to be known as A of X. Now we're going to move on to our roller. As we know, our roller will only have a restriction on the y-axis or a vertical force. So we're also going to assume for this one, I'm going to assume that it also goes upwards. We're going to call this d of y. So now that we have all the forces that we have to find, now we're going to start finding them. I'm going to start off with my um, x, my forces in the x direction. So we're going to start off with our sign convention that going to the right is positive and that the sum of the forces in the x direction have to equal 0, as we all know. So here we have our a of x, where we assume that it's going to the left, so that's going to be negative. So negative a of x. Then we have our 5 kips up here at the corner going to the right, so that's positive plus 5 kips. Then from there we have our 10 kips also going to the right, so that's another positive 10 kips. That all has to equal 0. So if we solve this for a of x, we would end up getting that a of x is equal to positive 15 kips. And since our 15 kips going to the right, and since our answer came out to be positive, that means that we assumed correctly. So that means that our assumption that it was going to the left is correct. So now that we know the value of a of x, we can now proceed to finding our y components. So here, once again, start off with your sign convention, upwards positive, so that the sum of the forces in our y direction have to equal 0. Then we assume that both AY and DY are going to be going upwards. Upwards is positive, so let's write that out. So we have AY plus DY has to equal 0. So in this case, we could rewrite this as A sub y is equal to negative D sub y, or D sub y is equal to negative A sub y. So to determine A sub y and D sub y, we're going to proceed to our moments. So when it comes to finding a moment, you're going to want to take a moment about a point where one of these two variables are not going to create a moment because it is either vertically or it intersects that axis of that point. So in this case, we could either take the moment at about point A, which will cancel out a sub y, which would give us the answer for d of y, Or we could take the moment about point D. That way we could in a way negate d of y and we would solve for a sub y. I'm going to take the moment about point A to solve for d's of y. So once again, our sign convention, counterclockwise positive, and that the sum of our moments about point A have to equal 0. So as you can see here, our a sub y will not be creating a moment since it is parallel to that axis. Then our a of x is not going to be creating a moment either since it intersects the axis of our point. But from there, we do have these 5 kips. So remember that moment is equal to force times distance. So our force is the 5 kips, and now our distance would have to be from here to here, which we know it's given to us that that distance is of 10 feet. Now we have to determine if that's going to be a positive or a negative moment. Since it is pointing to the right, about that point A, we know that's going to be creating a clockwise moment, meaning that's going to be negative. So we have a negative moment. The force is 5 kips. The distance is 10 feet. Now we're going to proceed. We have a counterclockwise moment of 50 kip feet. We know that counterclockwise is positive. So that's positive 50 kip feet. And remember, this 10 kips intersects with that axis about point A. So it, in this point, in this example, it's not gonna create a moment. But what we do have is our d sub y. Remember, our force is d sub y. That's what we're trying to find, the value of d sub y. So that's our force. And then our distance is going to be from here to here, which we know that also has a distance of 10 feet. Now we just have to figure out if it's going to be a positive or a negative moment. Since it is going upwards, we know that that's going to be creating a counterclockwise moment. So that means it's going to be positive. So positive d of y times the 10 feet. And we know that all of that has to equal 0. So as you can see, we would end up getting negative 50 kip feet plus positive 50 kip feet plus 10 of d sub y is equal to 0. So if we were to solve for d sub y, we would end up getting that d sub y is equal to 0 kips, meaning that our a sub y will also be equal to 0. Because if we were to input d sub y into this equation right here, we'd be getting that our a sub y plus 0 is equal to 0. So that means a sub y is also equal to 0 kips. So with that, we are done with part A of this example, finding the reaction components. So now we have to determine the member end forces and moments. So to do that, what we're going to do is we're going to be drawing again this structure, this figure that was given to us, but we're going to like break it apart so that way we could determine the member end forces and the moments. So we're going to go ahead and do that. This is for part B. For part B, I'm going to start off by drawing beam BC. We know that that has a span of 10 feet. We know also that we know that at this point right here, we have 5 kips. From there, That's all that we need to know. From there, we could proceed by drawing the span of AB. We know that we have 15 kips acting to the right, sorry, to the left. That is a pin. And that the span is also 10 feet. Now that we have that, we could proceed and draw the other side. We know that this is a roller, that it also has a span of 10 feet. We know that we have 10 kips going this way, and that we have a counterclockwise moment of 50 kip feet. So now that we drew everything apart with some space in between, we could start working on this. So I'm going to start off with point A, or span AB, and then from there just work my way around this. You could also start off from this side and work your way around this way. It doesn't matter. I'm going to start from point A. So to balance this out, as you can see, we have 15 kips right here, going right here to the left. So that means to balance out this part of the beam, we're going to have to apply, add 15 kips, but now going to the right. And now, as you can see, we have a couple going on, which these are our couples, and we know that couples create a moment. So this couple is creating a moment going clockwise. So that means that we're going to have to apply a moment going counterclockwise to balance that out. So we know that the moment of a couple is equal to the force times the distance. So that means we would have a moment going counterclockwise of 150 kip feet. And now like that, this part of the beam is balanced out. So now we could proceed. Since we added 15 kips going to the right here, that means that we need 15 kips going in this direction now. So 15 kips going in this direction. That's 15 kips. But now, since on this side we added 150 kip feet going counterclockwise, that means we're going to need a 150 going clockwise here. And now that we added everything, now we could proceed to come and look how we could balance this out. Here we have 15 kips going to the left, 5 kips going to the right. So that means we have 10 kips acting to the left. So that means that on this side, we're going to need 10 kips acting to the right. Okay, and then we have this 150 kip feet going clockwise. So that means we're going to need 150 kip moment on this side going counterclockwise. And just like that, we balance out this part of the beam, of beam BC. Now we could proceed and move on to the next beam. As you could see on this side of the beam, we ended up adding the 150 kip feet going counterclockwise. So that means that on this side, we're going to be needing 150 kip feet going clockwise. And since we have 10 feet acting to the right on this part, we're going to need 10 feet going on this side. So we have 10 feet. 10 kips. So now that we added everything, we could now proceed and look at this example. So now that we have that, we have our 10 kips right here and right here that balance out. But remember, these two are going in opposite directions, meaning that we have a couple. That means that these two forces are going to be creating a couple. And as you can see, this couple is creating a counterclockwise moment. So remember that that moment is going to be equal to the force times the distance. So we have 10 kips times the 10 feet. That means that we're having a moment of 100 kip feet right here going counterclockwise like how we said. And then remember, to that 100 kip feet, we are going to add this 50 kip feet that was already given to us. So that means that we have a total of 100 kip feet moment acting. And as you can see, we have a also 100 kip feet acting, but clockwise. So that means that, as you could see, our beam is balanced out. And that's how we know we did that we found the member end forces and moments correctly. Because if you guys did everything correctly, it should be balanced out in the end, and you shouldn't need to add or take away things. So we're done with part B, which was determining the member end forces and moments. So the last thing that we have to do is we have to draw the shear and bending moment diagrams for beam BC, which is this beam right here. So we're going to go ahead and do that. We're going to start off by drawing beam BC. So this is for part C. We have our beam BC, and we're going to be drawing out the forces that we found previously of our member end forces. So we knew that we had a 10 kips going in this direction. Remember, because we have 15 kips going to the left and 5 kips going to the right. So if we were to add those, we would just end up getting 10 kips going to the left. So that's where we got these 10 kips going to the left. We also had that 150 kip feet acting clockwise. And then from there on this side, we had 10 kips going to the right. And then we had that counterclockwise moment of 100 kip feet on the other side. And we know that this was a span of 10 feet. This is side B. This is side C. So to be able to draw out that moment, that shear and bending moment diagrams, what we're going to have to do is we're going to have to first split the beam BC wherever we want, right down the middle, whatever we want. And then from there, determine the shear and the moment before drawing out the diagrams. So what we're going to do is we're going to be splitting it right here. And then from there, you want to determine if you want to use the left side of the beam or the right side of the beam. Just remember the sign convention for this. If your split is on the left side of your beam, you want to remember that if we were to work with this side of the beam, you want to remember that since your cut is on the left side, that your moment is going to be going clockwise and that your shear is going to be acting upwards. Meanwhile, if you work with this side of the beam, your sign convention is going to be that your moment is going counterclockwise and that your shear is acting downwards. I'm going to be working with my left side of the beam, so my cut is going to be on the right side. So I'm going to redraw that. So we have our beam with our cut on the left side. And like I mentioned earlier, because of our sign convention, we know that shear is going to be acting downwards and that our moment is going to be acting counterclockwise. From there, we know that we have those 10 kips. And that's it. We know that this distance is of, we don't really know exactly where we cut it, so we're going to put that length of that beam to equal x. From there, on this side of the beam, we have our 10 kips. Then we have our 150 kip feet moment acting clockwise. So now to be able to determine our shear and moment diagram, all we have to do is just use our equilibrium equations. So we know that the sum of our forces in our y direction have to equal 0. Sign convention, remember upwards is positive. So here we have that our shear is going downwards, so that's a negative shear, so negative v of x. And that's the only y force or vertical force that we have here. So as you can see, our shear is simply equal to 0. Now we could proceed and move on to our moment. Remember, sign convention, counterclockwise is positive, and that the sum of our forces. I'm going to take this moment to be about 0.0. Our 0.0 is just going to be right here at the cut. So we're just going to put that moment about 0.0 has to equal 0. So remember, our shear is not going to be creating any moment since it lies right on that. It lies vertically on that axis of our point. From there, our 10 kips on both sides are also not going to be creating a moment since it intersects at that axis. So the only moments that we have here are just the 150 kip feet acting clockwise and our moment that is going counterclockwise. So we have our moment at x, or I guess you could call this the sum of the moments at x, I guess. So we have that our moment of x, remember it's going counterclockwise. We know this by our sign convention. So that's positive moment. And then we have a negative moment of 150 kip feet since that is acting clockwise, and we know that has to equal 0. So that means that our moment at x is equal to positive 150 kip feet. And like that, we were able to determine the value of our moment and our shear. Now that we have these values, what we could do is now we could draw those diagrams. So our shear diagram is going to be looking like this. We have our x-axis, which is our length of our beam. It represents the length of the beam. So we know that our beam goes up to a total of 10 feet. From there, we have our y-axis, where here it determines the magnitude, the magnitude or value of our shear. And as you could see, our shear is equal to 0. So basically, in a way, our shear moment can be left like that. You could just draw a straight line on the x-axis, because remember, our shear is constant throughout the whole beam. It equals 0. So that's what your shear diagram is going to look like. Now for our moment diagram, what we're going to have is, once again, our x-axis is going to determine our length. So we know that our beam goes up to a length of 10 feet. From there, our y-axis is going to determine our moment value. And as you could see, our moment at x, or throughout anything, is constant because there is no variable right here. So if there was a variable right there, that's where we're going to be inputting that value to see what's the value for our moment at each length. But as you could see, it is going to be a constant. So our moment diagram is going to be looking like this. So we're going to assume that right here, this is 50 kip feet, this is 100 kip feet, and this is 150 kip feet. So our moment diagram is going to be constant throughout the whole beam. And we're just going to annotate that right here is 150 kip feet. And just like that, we were able to solve for the 3 parts of this structures example that I made. So remember in this example, we worked with finding the reaction components, determining member end forces and the moments, and drawing the shear and bending moment diagrams for the beam BC. Please feel free to like this video and to subscribe to our channel if you guys would like to see more videos like these.